that end effector, Professor Rodriguez will tell us more about that. It's a very clever design and really embodies the spirit of what we would like to see here at the Amazon Picking Panel. So, Professor Rodriguez.
Hello, thanks for the introduction. Today we put together a demo which is going to show the robot doing things that are quite much simpler than what the challenge is supposed to do, but it's designed to demonstrate the versatility of the gripper that we all put together. We sort of approached the picking task by thinking that we had to come up with a way of integrating different picking modalities. You see different examples for different objects. The system will choose to either grasp with the strong fingers or with the phalanges or different types of suction. And the idea is that it will decide for each one of these objects what is the best way to pick it. And we'll go through the two different tasks. First, three examples for the stowing task, picking from the bin and stocking in the shelf. And then a few examples picking from the shelf and putting them in the bin. So, I guess we can start.
We are going with flow point.
Yes, first we're going to do the stowing example. You see that the first thing that the robot does is calibrate the shelf because the shelf could move, and that has a big influence on the type of motions that the robot can do so that it doesn't collide with it. And then it goes to perceive on the shelf. Because we have a very precise industrial manipulator, and the camera is mounted right at the end of the robot, we can benefit from that to get different pictures from the bin and then putting them all together. The perception system, which was developed with the help of colleagues from Princeton, maybe I can pass the mic to them to explain a little bit how it works.
Yeah, so the vision system was developed at Princeton with the Princeton Vision Group. It works by taking 15 color images and depth images, and then it uses a convolutional neural network for object segmentation. So it classifies each pixel as belonging to one of our objects, or not belonging to any of the objects. With that segmentation, then it just uses ICT to get the pose of the object. For suction, it oftentimes goes to just the point cloud and uses Android for better locations around the object.
So you saw the first example where the robot decided that because the book was placed on the side of the wall, it was much easier to just use the suction cups on the side of the book to pick it up. And it decided to use two because the book was a wide object. And then it went to place it in a big bin because the book is quite big. The thing is that quite often we don't really know what the robot is going to do next because it has sort of a mind of its own, right? It has some constraints of the things that it can do and the things that it cannot do, and then it decides what is the best thing to do next. I think in this case it's going to try to grab a t-shirt that is at the bottom of the bin, for which it does a slow motion that is guarded by sensors that we have on the suction cups, and it detects contact with the ground or any other objects that it could detect in the way, and when it detects, it stops, and then it closes on the object. It pinches, and then it will use a few checks that we have to detect if this is the right object and if it got it, like looking at the width of the gripper, how much it's open, or using the camera to look at the object itself. Then there's just one object remaining now in the shelf, which is a case of pencils. And in this case, again, because it's flushed against the side of the bin, it's very difficult to use just a standard grasping technique. So you will see how, hopefully, we'll deploy the spatulas on the gripper. We're thinking now, what is the best way to do it? Oh, it's gonna suction it. Okay. No.
What? Yeah, it's gonna suction.
It's gonna use suction again. So yeah, as I was saying, we don't really know what's going to decide what to do until it does it. If it doesn't get the object, it tries again. And in this case, I have the feeling that it won't get it because it's too shallow for the gripper to get there. It might get it right at the end, but no, it didn't. So now it thinks Camcorder will try a different crafting primitive. So it should know that it didn't get it now. And it's going to decide whatever is the next best thing to try. And the next best thing to try is to scoop it and using the spatula. Or at least that's what it thinks. So the spatulas, they have string gauges that allow it to detect contact with things. And now it pushes against the wall until it builds a certain amount of pressure, preload, so that it can flash against the side of the object. It puts the other finger on the other side and then it closes the gripper. And then it comes back, this time successfully. Now we will check whether the grasp was successful. And in theory didn't get it. So now we're going to stop this task. Well, is it going to try again? So, yeah, let's just try it and see what it does. It should do vision again, right? Oh, just stop. Yeah. Okay. Okay, continue, yeah. After placing the objects, just in case one of the objects wasn't fully inside, it pushes to make sure that it's in there. And it remembers what pins it has put objects to make sure that they don't stick out. Okay, so this is the end of the first demo.